Okay.
Okay, we have our next speaker here with us already, Tim Spuck. Tim, nice to have you here. Thank you for coming. And Tim is going to talk to us about IDATA, I think this is the name, and Afterglow Access software. So Tim, the floor is yours. You have 15 minutes if you want questions, 20 minutes if you don't want any question, and I'll let you know when you have 5 minutes left.
Hey, great. Thank you, Rosa. And it's great being here. Good to see everyone. I'm going to go ahead and share my screen here. One moment. At least I think that's what I'm going to go ahead and do. Oh, hang on here. Something did happen, but we will.
We don't see anything yet.
Okay, well, we are going to go here. So I'm going to take my time that I have, and I'm going to share with you a bit about Innovators developing accessible tools for astronomy, or IDATA. And the website here is just idataproject.org. So IDATA and project.org. And this is a project that was funded by the U.S. National Science Foundation. And the focus of the project was actually to explore computational thinking in astronomy. But one of the side benefits of it is that we were engaging students in developing a software tool for to make astronomy more accessible to the blind and visually impaired. And so as part of the project, we engaged high school students and some middle school students and their teachers in the software design and development process. And so what I want to focus on today is really the astronomy software tool called Afterglow Access. And this is Afterglow Access. Basically, it is a tool that is server-based, so it's browser-based, so you can actually, anybody can access it. And the way that you access it, I'll just show you very quickly. If you go to the website and you go to Resources, and if you just scroll down here to Afterglow Access Software, and you can click on this button that says check it out. Afterglow Access is free. You do need to have a Gmail account, a Google account, or a Skynet account in order to use it. We also have some additional resources here that you can use. One of those are some tutorials that are available to go ahead and watch before you use it. At this point in time, we do not yet have the software manual available, but we are in the process of creating an accessible, a BVI accessible software manual that will help explain the various features. So going back over to the software, you might be asking, well, how does it work? Basically, the software tool itself has all of the normal features that you might expect, or the majority of the normal features that you might expect in a data analysis package. So you've got your display settings, your histogram here. You've got, you can go ahead and change it. Are these bright objects? This is the default. Are these faint objects? And so these are common features that you see in other types of software. What kind of stretch mode do you want to use? A linear, logarithmic, square root. All of the standard features. If you don't want a gray map, you can go to a heat map. You can go to, and invert that. So you have the normal display functions that would typically be used for a sighted individual. But up here, we also have some features, and as we've discovered recently, we have some things that have been, that that got broken in the latest updated version. But we have a theme editor, so we know that for BVI individuals, sort of a yellow on black is really a good scheme to go ahead and use. But you can also change this if you prefer indigo on light. I'm just going to stick with yellow on black for right now. You can change the font, and this is the functions that we need to have our software person do a quick fix on, but making things extra bold, extra large, so that they are easy. It's more easily used for those individuals with visual impairments. You can have your typical histogram, or I'm sorry, your header file, so that you can get details of the image. We have custom markers. We have a plotter, so that if you want to go ahead and plot through an object. So all of those features. We've got a photometry tool. We can do image arithmetic, basically adding images, normalizing them. We have a WCS calibration function, a liner, and of course a stacker that can be used. But this is the tool that I want to spend most of my time presenting today about, is the way that we've integrated sonification into the tool itself. So you might be asking, well, how does this work? Well, basically, if you can envision along the x-axis of the image, there's a piano keyboard. Lower tones are off to the left, mid tones are in the middle, high tones are off to the right. And then we actually do a sweep or a scan up through the image from the bottom to the top. And each row of the pixels is just like striking the keyboard at each row. And so we're going to set my duration here for 10 seconds. I've got 22 tones. And this is just a dummy image where you're going to be able to hear a star here, a star here, and a star here. So let's see if the sonification works.
Tim,
Yeah.
did you share the sound of your computer? You probably didn't. When you share your screen,
Okay,
you have
so
to click in the box that says share the sound of the computer.
all right, I'm going to stop sharing, and I'm going to
left, Tim.
Okay, thanks, Carl. Right there, share sound. We're going to go here, share it. Okay, now let's try this again. Can you hear it?
Perfect.
Okay, because I'm glad you can hear it, because for one reason or another I can't. So it is, but that's not important. I know what this sounds like. So you heard a low tone in the bottom early on in the scan. You heard a mid tone in the middle of the scan, and you heard a high tone in the latter part of the scan. So this was a 10-second sweep. So if I wanted to, I could actually navigate around this image. I could say, you know what, I heard something that sounded interesting in the time navigation, and it was a low tone. And so you've just zoomed into the bottom left-hand portion of the image without the aid of sight. So that you can do this, you can actually zoom around the image with just the sonification tool. How does this, let's just go, so what is it, what about when we're dealing with an image? What does something like this sound like? And so let's just sonify this globular cluster. And I'm going to do one more pass for you. And this is one of our test images that we've done with individuals, both those who are BVI and basically those sighted individuals without showing them the image itself. And individuals have been able to basically identify that there's a bunch of stars near the center of the image. And some individuals who, with some astronomy background, have been able to identify this as a globular cluster without seeing it. Let me show you another image here. This is going to be interesting. I want you to watch for this satellite right here and listen to what you hear. Okay, so you heard somebody just kind of like striking their finger across the keyboard. And we'll let you listen to it again. You'll hear this low tone, the bright low tone star in the bottom left. So really what we were after with this project and in creating Afterglow Access was to do a proof of concept that we can actually take an image array and turn it into sound in a way that an individual without sight or without using sight can go ahead and identify or distinguish features. And so we actually have a proposal submitted to NSF. We have another one that's going in here in October to actually continue this work and to create additional tools within Afterglow Access that actually use text-to-speech or that use sonification in order to explore astronomical images or to do data analysis. One of our visions for this is that, if you take a look, for example, at a radar weather map of thunderstorms moving through an area, and you look at an infrared map of the star formation regions around the constellation Orion, there's really not a lot of difference in what those images might look like. And so what we are wanting to do is to take this tool and also build it so that you can import other kinds of images, geosciences images, and use some of the similar sorts of data analysis features with this software. The tool itself does have the capability to load a JPEG image. It is right now, it's very slow in what it does in doing this. But what it does is it actually, when it loads it in, it breaks it off into an R, G, and B filtered images, and then you can actually sonify those as well. This tool is not that, like I said before, this is very early on. It needs a fair amount of work to streamline the way the data is being interpreted, so that it things move a bit faster. But for example, here's an image right here. Again, we're talking just proof of concept. This has a long ways to go, but we can actually sonify this image here as well. So we think that it does have tremendous capabilities. Like I was saying before, we are in the process of coming up with a user's manual that actually will help somebody to be able to load up an image, get started with it. I would imagine that most all of you, with your expertise in this area, could get into the software and figure out the tools pretty quickly. But please feel free to check it out. Go in. It doesn't cost anything. Like I said, if you have a Gmail or a Skynet account, you can go right in through the AUI web or the idataproject.org website, get access to the software. You can share that with anybody that you would like. And like I said, we're looking forward to making some modifications and improving the tool in the future. So any feedback, of course, would be much appreciated. And so I will stop there.
Thanks a lot, Tim. That was quite impressive. Maybe you can put the link on the chat for the people willing to try it out a little bit.
Sure.
I don't see any questions from the audience. I have a question for you. Does the software allow slowing down? For instance, if you are scanning an image and you find something, can you stop and say, okay, go slowly here?
You can zoom into that area and you can slow it down. So if you are, let me just do something here real quick. I'll go back to sharing screen. But right here, Rosa, you can say your duration. So I can increase that time and make the scan go slower. Or if I'm zoomed into, we're just going to say this satellite, I'm going to say custom, and I'm going to say, all right, it's, I heard something, it was very late in the scan, so I'm going to zoom right into that area, and I'm just going to sonify that area, and we'll say it's a 10-second, and I think I forgot to share my sound again, so you're not going to hear it. But you can slow it down like that.
Okay.
So I can even take this and say, well, you know, it was time navigation, it was late in the scan, and I can even zoom in further. So we're trying to create a zoom function or a navigation around the image or the data array. We're trying to do that in a way that it does not require sight.
Okay. Thank you for that. Well, we do have two questions here. The first one is from Vanessa asking, is it possible, it's possible to sound the music on a dynamical image as a variable star?
So you can, so hearing, this is something, a feature that we do not yet have built in, but it is in the queue. It is planned to be built in, so that you can actually look at or hear the variability of an object. If it's a moving object like an asteroid, we can do that through you know, basically adding images, and then you would be able to pick out the moving target. We have done some work there.
Vindra is asking if it has been tested with many visually impaired people. How was the feedback?
So it has been tested with a number of visually impaired individuals, in particular students from the Wisconsin School for the Blind. The feedback has been very positive, but as I've said before, there is additional work, functionality that needs to be added to the software, as well as a training tutorials on really how to use this functionality, or how a BVI individual can use the functionality. Okay. So we're sort of in progress on that.
Carl, you have a question? This time we still have 2 minutes before the end, so it has to be a quick one. You're muted. You have to unmute yourself.
Great work, Tim. Two quickies. So a random visually challenged person can come to idata.org and do this?
Anybody can access the software. It's
materials around it so they can get it. They understand.
So I won't say, Carl, that an individual could take what there is right now and use it off the shelf. We have to finish building the resources to go ahead and so that you can have a training program, whether it's for a sighted individual or a BVI individual. We're in the process of building out some of those resources.
Just another remark. It seems to me we didn't, and you probably tried it and it didn't work, but it seems to me we're not using the dynamic range in volume. And you know, like that galaxy, I thought should have made a as it gone over, should have been a hum. Low frequency hum over it, and I know many VDI people have exquisite volume differentiation.
Yeah,
I wonder if we're not exploiting that all the way.
Well, Carl, I think you bring up a good point. And one of my things that I've asked for is that I want basically a new user to go to the software. We should have some sort of hearing test so that we can get the individual's dynamic range and then map it to that. But you will hear, Carl, if you have headphones on when you're using this, which is much better. If you also have a good set of headphones, you will hear that when it passes over the galaxy, we actually add white noise to any sort of nebulosity. So you do get the shh.
All right.
It indicates it.
Very nice. Guys, I'm sorry. I think I have to cut the conversation. Team, that was I think I heard you talking about this. It's nice to see it materialize. Thank you very much. That was really very interesting, and we're looking forward to continue hearing about the developments of this. Thank you so much for this. I see
Thanks,
Gustavo
Rosa.
there. Gustavo, you're pounding.
I was going to make a compliment that you are learning to chair a session accordingly.
I am learning.
Not so
Sticking
bad.
to the schedule.
I always did. That was not fair. Okay, well, now I am 1 minute late. So, Tim, thanks again. That was brilliant.